So it's my pleasure to introduce Tim Frazier. Tim has an undergraduate degree in mechanical engineering from Vanderbilt University and published papers on eclipsing binary stars. He earned his MFA from the University of Florida and has worked in over a dozen international collections, including the Art Institute of Chicago and the Museum of Modern Art in New York City. In addition to his fine artwork, Frazier was the faculty sponsor for a NASA-funded high-altitude balloon project for 6 years, which launched experiments and cameras to altitudes in excess of 90,000 feet. In 2009, he headed a team from Idaho State University that built an experimental capsule which was launched into space by NASA. He is also an avid outdoorsman, fisherman, woodworker, telescope maker, and past president of the Magic Valley Astronomical Society. So welcome, Tim, and thank you very much for joining us here. I think I'll just turn it over to you and you can get started.
Okay, thank you so much. I want to say also that there is a sheet of information relevant to this talk that will be emailed to you when the talk is over. And it contains links to various things that I will mention during the talk. Okay, well, I'm going to go ahead and get started by saying simply what I would like for everyone to do is to go out and look up at night. And that's sort of the goal of this talk, to get you familiarized with what constellations are up now and which ones are climbing in the sky. So let's start with something like, come here, there we go, like this. This is an image looking straight up at about midnight tonight. And what you're seeing is the Milky Way arm that's going through the constellation Cygnus, the Swan. Now, this particular photograph was made with a lens that has a magnification of 1. In other words, the magnification is the same as the human eye. The fact you can see so much is because the shutter was open for about 3 minutes and it captured all this extra light. And as we look at this, we see a very bright star here. This is Deneb. And then we see, what in the world is this? You've got this little stringy thing down here. You've got other stuff. Well, this is the thing about getting started in astronomy. What is up there and when is it up there? And that's what I want to start talking about. If we were to look at a map of this constellation, it would look like this. And we can see all of these objects here. They're marked with different indications and symbols. The thing about it is, if you wanted to find an object, say this thing labeled here at 7,000, one way of doing it is by using a system of coordinates not unlike longitude and latitude on the surface of the Earth, only these are projected against the sky. And they're called right ascension and declination. So if I'm looking at 7,000, I say, okay, that's at about, say 42 degrees, and then this is what, 21 hours. And if I had a telescope mount that had these indications on it, I could point to that object. This is a way of finding things. The problem is it's a rather long and steep learning curve and you need special equipment. The best way to find things in the sky is learn a few constellations and then navigate point to point using that information. Now, to begin with, what in the world is up when? And for that, there's a device called a Planisphere. I'm going to show one. I think the next slide has one. And then it's always good to have an almanac that's going to tell you what's going on. What's the phase of the moon? Will there be a lunar or solar eclipse? And then, of course, sky maps. Now, all of this information can be found online, but it's really nice to have a hard copy you can take out into the field and look at. One of the resources that I use quite a bit is Sky and Telescope, and this is one of their web pages. Sky and Telescope is an astronomy magazine that's been around for over 80 years. Okay. This is a planisphere. And the thing about a planisphere is it has a map of the sky that's on a wheel. And you spin the wheel and line up a time and a date, and it will show you here what's in the sky. Somebody, Linda's holding one up. I can see that in the screen. Yes, you've got your planisphere. Excellent. The spinning point here, this brad route about which everything rotates, represents the north celestial pole. That is, if you projected Earth's rotational axis into the sky, this is where it would go into the celestial sphere. Everything appears to revolve around this because, of course, the Earth is rotating. Shameless plug number one, you can also buy a planisphere from the Harrod Center on CSI's campus. They have an observatory there that's open to the public regularly, plus an excellent planetarium with weekly programs. Okay, another way of learning the sky is this card game called Constellations. And basically in this game, you win tricks, and then you get to play your cards and eventually build a map of the sky. Cool thing about these cards is when you're done playing the game, you can turn out the light and they glow in the dark. This use of cards to learn the constellations is not new. And I'm going to show some much older cards here in just a moment. Another resource, of course, are any sort of local resources like our library. That book, by the way, that Kristen held up is excellent. And its writing about the constellations is really fascinating. Anyway, the Harrod Center here, again on CSI's campus, this is where the Magic Valley Astronomical Society meets every month, the second Saturday. We're not meeting now for obvious reasons, but we hope to be able to start meeting again in the fall. There are also handbooks. This Observer's Handbook is published by the Royal Astronomical Society of Canada, and it comes out every year, and literally it goes day by day of what is in the sky when. I always get these. They're not cheap. They're about $30, but they give you all the information you need about what's going on that year. Also, a good set of star maps is critical. This one, the Cambridge Star Atlas by Will Tirion, is a very good one. It has, of course, maps of all the constellations, and it's divided up by the seasons of the year. The one that I really like to use is this one. This is Sky and Telescope's Pocket Sky Atlas. It's a little bit bigger than a paperback book. It's laminated, so when I spill coffee on it, of course, it doesn't hurt it. But it's also very, very detailed. You can see from this depiction, this is the constellation Gemini. It has all sorts of different objects on it. And where you see this blue swath cutting through, that's where our Milky Way galaxy, that arm of the galaxy, is. Now, one way of finding objects in the sky, not using that coordinate system, is something called star hopping. And I did this when I first began observing, and I did it all the way up until just a little while ago. And what you end up doing is finding a constellation, in this case, Hercules, and looking at bright stars and the object you want to view. In this case, what we're going to be finding, star hopping to, is M M13, which is a concentrated cluster of stars. In a lot of these things I'm going to show you, the M designation is by the numbers. M stands for Messier. Charles Messier was a French astronomer in the late 18th, early 19th century who mapped position of what he saw as fuzzy patches in the sky. And he did this and marked their location so people searching for comets wouldn't confuse them with those bodies. Okay, if we want to find M13, the first thing we do is locate Hercules, which is like a weird backwards K or an H, and it has this keystone feature in it. And we would find this star designated by the Greek letter eta, and down here is the star Zeta, again, the Greek designation. And if I go about a third of the way down in a line between the two, I should find M13. And that's how you star hop. You start from a place you can find and hop your way to the object. Something like M13 is bright enough, it's easily seen in a pair of binoculars. Well, I mentioned the Greek alphabet, and whenever you look at a modern star chart and you look at the designations of the constellations, of the stars, and the names of the stars, you are seeing an overlay of three ancient civilizations who had very good astronomers. Now, I'm talking in the Western tradition right now, okay? The Romans contributed the names of the constellations. They're all still in Latin. The designation of the stars, as far as the brightest one being designated with the Greek letter alpha in a particular constellation, the next brightest one in that constellation would be beta, etc. Obviously, that comes from the Greeks, the ancient Greeks. The names of the stars are all Arabic. So we see these three cultures overlaid. Now, I mentioned this is Western tradition. Eastern tradition would include countries such as India, China, Japan, Korea, and all of these countries had marvelous astronomers as well. And some of their ancient records, in particular some from the Chinese, have been used in modern times to identify when a particular artifact in the sky was created. For instance, the Chinese in 1054 modern era noted there was a guest star in the sky, which is such a polite way of putting it. You know, we have a guest star, you know, we'll put them in the bedroom over here or something. And anyway, it was visible for about a month and a half. It was so bright, it was visible during the day. Well, what they witnessed was a supernova. Well, modern times, we look in that position that we got from the ancient Chinese maps, and lo and behold, there's a supernova remnant there that we study. In fact, Messier labeled that as his first object as M1. Now, the Messier objects, I mentioned those before. Here is a chart showing all 110 of them. In that handout that's going to be sent to you, I've included a link to 100 binocular objects, that is, astronomical objects that are easy to see with binoculars, and a lot of those are the M objects, and there are a number of them that are visible in the spring and summer sky. Now, as far as the brightness of stars, I mentioned that we use the Greek alphabet for those, brightest being alpha. But when they initiated the whole idea of, let's say, which stars are brighter, it was about 1,500 years ago. And when they started, they say, okay, the brightest star in the sky, stars in the sky will be given the designation 1. The next brightest stars will be 2. The ones after that will be 3. And that was fine until somebody said, hey, this one is brighter than a 1. So they said, okay, we'll make that a 0. Well, what about this one? It's brighter than 0. Okay, we'll give them negative numbers. And so we're kind of stuck with that system now, as awkward as it might be. Anyway, so this is an image of the bright star Sirius, which is in the constellation Canis Major, a winter constellation. It's the brightest star in the heavens at a magnitude of minus about 1.5. Well, if we look up in the sky, and we're going to orient ourselves in the sky to find these constellations for the spring and summer, I'll begin by looking north. Now, what we see here is a photograph where the camera is pointed toward the celestial north. And then it's on a tripod. You open the shutter up for a long period of time. It looks like they left it open for several hours. And what you get are star trails like this. And of course, we can see that the stars appear to rotate around this celestial North Pole. Of course, this is the Earth rotating. But there are constellations that are close enough to the North Celestial Pole that they're always visible. At some time every night, you can see these constellations. So we'll start there, and then we'll work to a different part of the sky. Well, the most recognizable constellation near the North Pole is, of course, Ursa Major, the Great Bear. And within it, we see this asterism, that is, group of stars known as the Big Dipper. You know, it's interesting about this constellation. Every major culture saw this grouping of stars as a bear. And I don't know, it's kind of, you got to use your imagination with some of this. But from a good dark sky sight, you can easily see all of these stars. With a little imagination, you can certainly envision a bear. This is a photograph of that asterism. We see the Big Dipper here. Okay. And if you remember from our last lecture, I talked about this star, that when you look at it with a telescope, this bright star is actually split into two stars. Okay. But,
hey, Tim, excuse me.
yeah.
What is an asterism? Is that a constellation?
An asterism is just a pattern of stars. And so if you look up and you see the Big Dipper, well, it's not really a constellation. It's part of the constellation Ursa Major, but its pattern is very recognizable. We'll talk about another asterism in a constellation in just a few minutes. Okay, other questions?
Don't have any questions yet, but I certainly encourage people to type your questions into the chat box.
Okay, all right. Well, I mentioned cards, how you can learn the constellations from a card game. Well, it's not original with us. The Victorians, who were really into naming and knowing things like this, had a whole series of cards printed up, one for each constellation, so you could study and learn them. And here is their depiction of Ursa Major, the Great Bear. We can see here the Big Dipper in here. These are wonderful cards. I mean, the depictions are just great. Okay. Now, the important thing about Ursa Major and the Big Dipper is that the two stars at the end of the bowl of the Dipper can be used to point to Polaris, which is a star that's very close to the North Celestial Pole. And it is in the tail of the constellation Ursa Minor. So these are pointer stars that approximately point toward Polaris. Okay. We're going to use these pointer stars in a minute to go the other way and point to something else. While I was looking up things for the Big Dipper, I ran across this painting by Vincent van Gogh. When he did Starry Night, he didn't just do one painting. He did a whole series of Starry Nights. And this one is called Starry Night over the Rhone River. And of course, you can see the Big Dipper here. And from its position in the sky, and assuming with this couple here wandering around, that it's early evening, this painting was probably made in November. Now here is another constellation that's circumpolar. That is, you can see it every evening of the year, and that again is Ursa Minor, the little bear. Here we see the Big Dipper and the stars pointing up to Polaris, which is right here. If you look at the Victorian card for Ursa Minor, it doesn't even get top billing in its own card. You know, it gets overshadowed by the giant Draco the dragon here that winds around the little bear. Another circumpolar constellation is Cassiopeia. And you see it's sort of this W pattern, or later on in the night, that'll become an M. I'm showing this one because it's on the other side of the pole star, that is the North Celestial Pole, from the Big Dipper. So one of these will be prominent in the sky as the evening comes on every day of the year. Okay, if we look closer at Cassiopeia, we can see part of the formation of where they get the idea that this is a throne with a queen. If you can imagine the throne on its side, here is the seat, these four stars. Here is the back of the throne, and the head of Cassiopeia is up here. All these stars that you see are, of course, all part of our Milky Way. This is what that looked like if we put the chair right side up. And here is the vain queen, Cassiopeia. She figures largely in Greek and Roman mythology. Her beautiful daughter, Andromeda, was chained to the rock where the dragon was going to come and consume her. And the hero, Perseus, flies in on Pegasus, the horse, and rescues her. It's a great story. Now, let's get to the first of the spring constellations. Now that we know what's in the north, let's turn our back to that, look to the southwest, and just as it's getting dark, you will see this constellation. This is Leo the Lion. Now, last evening when I went out and looked at this, this asterism of stars, this sickle here, is actually pointing down to the west. Okay, this is the bright star Regulus, and of course we see the pattern. Now this is a fairly large constellation, so it's pretty hard to miss, but another way of finding it is by going back to the Big Dipper, and instead of taking the two stars at the end of the bowl to the open side of the bowl, go to the closed side of the bowl, and you can draw this line and will lead you straight to the constellation Leo. And this is how Leo was seen by those the wacky Victorians. Here we see Regulus, very bright star at the heart of the lion. We come up and we can see that sickle. And then out here toward the tail is Nebula, which is the tail of the lion. Again, you see the names of these stars are Arabic. I'm sure I'm pronouncing these wrong, but it's the best I can do. And we see Leo Minor here, which is a very dim constellation. I've never really patterned this one at all, but Leo is certainly very obvious. Now, if I look at a star map of Leo, this is what I'll see. Here's Regulus. Here's the body of Leo the Lion, Nebula. And we're seeing some M objects, some things that Messier had identified. M105 and 96, M65 and 66. So let's go ahead and we'll take a look at the M65 and 66 as if we're looking through a telescope. And this is what we would see. And you see three objects, not just two. Now, M65 and 66 are over there, here, 65 and 66. And you can see from this photograph that they're obviously spiral galaxies. You can see the arms here. But what about this object over here? This is NGC 3628. NGC stands for New General Catalog, and it's another catalog of objects in the sky that contains thousands of entries. What we're looking at here is a spiral galaxy like this, but we're seeing it edge on. And you're looking here into the very dark dust lanes of those spiral arms. This is known as the Leo triplet of galaxies. These are visible through binoculars. It's really remarkable. These three galaxies, which are at a distance of about 35 million light years, okay, are gravitationally bound. That is, they actually are fairly close together. This is not unlike the trio of galaxies that include the Milky Way galaxy, our galaxy, the Great Andromeda galaxy, and the Pinwheel galaxy. We saw those three in the last talk. Okay.
Quick question.
Sure.
So the NGS, is that correct? NGS. So that's an edge on galaxies. So that's essentially what we're seeing when we look up at the Milky Way here, right?
That is
so
correct.
We're looking at the edge of our, kind of the,
we're looking into the spiral arms. Yes, mm-hmm. That's exactly what we're doing. Yeah, it's NGC. C for catalog. Usually on star maps, they leave off NGC. They just put the number because it's so common designation. Yeah, we are literally, when we look in particular toward the south in the summer, we can see that dark line of one of the spiral arms, that space here. Now, other questions? Nope.
No, there aren't any questions, okay. But let me just urge people again, please type questions into the chat box. We'd love to respond to them. Well, we'd love to have Tim respond to them.
Okay, put me on the spot. Excellent.
Yeah.
Okay, there were two other M objects on that map of Leo, and here they are. This is M105 and M96. By the way, in that previous frame where you saw the two M, I'm going to jump back there for a moment. We saw these two M objects. Why Messier did not see this one, I don't know, because it's equally bright. A lot about his particular catalog is kind of hit or miss. But how he missed this one, I don't know, because you can get all three of these galaxies in the field of a small telescope very easily. Okay. Well, here is M105 and M96, and we can see them. We're looking down on them from our point of view, and we can see they're obviously spiral galaxies. Okay. I want to caution people when they look through a telescope after you've seen a photograph like this, you're not going to see them like this because these photographs were made over a long exposure, and they capture light to show you detail that the human eye simply cannot see. Also, a lot of the photographs you see in books or online, when they show you a celestial object, it might be far more than just visible light that they're showing. What they could be doing, and in many cases are, is take an image of the infrared radiation and an image of the ultraviolet radiation, neither of which we can see, and superimpose that on top of the galaxy. They'll take the infrared data and make it a particular color of red that we can see, and the ultraviolet a particular color of blue we can see, and drop it on top of the image. And lo and behold, you see all this stuff in it that there's no way you can see with the naked eye. So some people, when they look through a telescope, they're a little disappointed. I have to remind them, those photons, like from these objects, traveled for 35 million years just to reach your eye. So appreciate them, please. Okay. Well, if we go a little bit farther up towards zenith from Leo, we come to the constellation Virgo. Now, Virgo has a very bright star, Spica, in it, and you'll notice it's designated as Alpha Virginis. And it has this little sort of head shape here. And you see, here's Leo. This is Nebula here, the tail of the line. So it's very close. Look at all these M objects and other things up here. Oh, and some of these Arabic names of stars, Vindimiatrix is one of them, have way too many vowels in them, I think. They're awfully long and difficult to pronounce. It makes it quite a challenge. Okay, but if we look at a map of the sky, okay, we'll take a look at this. This is what it looks like. You see, it's rather nondescript. Here's Nebula here, and here's sort of the head of Virgo. Here's Spica. All right. This is the way the Victorians depicted Virgo. Now, she is shown in this depiction with angel wings because during that time, from Middle Ages forward, they used this constellation to represent the Virgin Mary. The earlier civilizations, in particular the Greeks and the Romans, had Virgo represent Ceres or Demeter, the goddess of the harvest. So she's always depicted here with a sheaf of wheat and with a plant. Okay. Now, if we go into that spot that the map showed there were a whole lot of M objects, this is what we see. We are looking into a gigantic cluster of galaxies. This is known as the Virgo Cluster of Galaxies. It's at a distance of about 60 million light years. So the light that we're seeing in this image left these galaxies shortly after the dinosaurs became extinct. Now, in this cluster, everything that's fuzzy is a galaxy. There are about 2,000 galaxies in this cluster. This cluster is gravitationally interactive, and it's certainly possible with just a small telescope to literally make out dozens, even up to 100 different galaxies in this cluster. Okay. If I zoom in on just one of these, this is M87. It's an elliptical galaxy. You see, it doesn't have spiral arms. It's just this sort of big football-shaped conglomeration of stars. Elliptical galaxies are gigantic. They can have up to 1 trillion stars in them. How they form is a bit of a mystery, whether they actually formed in this shape or this is a consequence of two spiral galaxies merging. And by the time their gravities got done doing their dance, this is what you end up with. Also notice that all of these other little fuzzy spots you see all around, these are all galaxies, each with hundreds of billions of stars in them. Now this M87 is easily visible in binoculars. Okay. Another feature in this cluster of galaxies is this marvelous line of galaxies that you see here. This is called Markarians Chain, after the Russian astronomer Markarian, who did quite a bit of pioneering work on the study of these particular galaxies. And again, you can see all of these other slashes and spots and blobs that are other galaxies. These two galaxies in here are easily visible. This is M84 and this is M87, the one we just looked at. Both of these are easily visible in binoculars. By the way, when I talk about using binoculars, it's my strong recommendation that you mount the binoculars on a tripod. You can get a little mounting bar for about $12 to $15 that will permit you to hook your binoculars to it, and then the bar will connect to a tripod, and then it won't be wiggling as you hold it. And you can see so much more. It's also really cool when you find something, then you can share it with somebody else. Okay. Now, all of these galaxies in this cluster are gravitationally interactive. And some of these galaxies, like for instance, these two you see right here, are really very close together. And the powerful gravity of these galaxies can work on a galaxy. And in particular, this galaxy, which is kind of looks like a hot mess, this is NGC 4388. Its outer edge, you can see, sort of looks like one of those elliptical galaxies, but the inside you kind of see sort of a spiral structure, like it wants to be a spiral. What's happening here is very simple. The galaxies nearby are exerting huge gravitational forces on this and are kind of tearing it apart. All this blue material in here that you see, all of this is very active regions within this galaxy. This is where stars are forming. I know in our last talk I showed star formation areas as red. These in this particular image are depicted as blue. You can also see up here a marvelous spiral galaxy. Spiral arms, very easily seen. Okay, if we continue going up in the sky, by about midnight, this constellation, Lyra, will be overhead. Now, Lyra is a small constellation, but it's easy to see because it has this very bright star, Vega, in it. Okay. If we look at it, it shares its billing with several other constellations. Here's Lyra, the lyre, of course, the stringed instrument. We see Cygnus, the swan. Vulpecula, the fox. Looks like it's gotten a hold of a signet here. And then Lacerti, the lizard. It's really interesting. Cygnus and Lyra are very easy to see. Vulpecula, I cannot make a fox out of that no matter how much I've tried. But it's definitely in that region of the sky. Okay. Now, if we look at Lyra, the lyre, we see Vega, the very bright star. And from my last talk, this is Epsilon Lyra, which you can see as two stars. And then when you look at it through a telescope, each of those stars are doubles. So it's a double star. And down here, between Gamma and Beta Lyrae, is this M57. If I was star hopping, this is how I find it. I locate Vega, find this trapezoid, go to a leg of the trapezoid away from Vega, and go about halfway between these two stars and start looking. this is what you would see. This is the Ring Nebula, M57. Now, this little star in the center is old and it's dying, basically. And as part of its change in thermonuclear reactions, it has sloughed off the outer shell of itself. And rather than being a chaotic ejection, this was very symmetrical and it formed this cosmic smoke ring. When you look at it through a telescope, what you'll see is like this little sort of blue, gray, green donut. The Ring Nebula is, of course, this ring is expanding at about 19 to 20 miles a second. The colors that you see here do represent the material that's in this gas. The red that is glowing here represents hydrogen. Okay. As I mentioned in my talk before, when you see a nebula like this that's glowing, the action that makes it glow is exactly like a neon sign. The gas here, the hydrogen, is being excited by the light of the stars around it and emitting light at a very specific wavelength. In this case, it happens to be red. These other colors depict other elements. This green and blue in here represent oxygen. Well, if I go a little bit to the northeast of Lyra, I'll see our constellation of Cygnus the Swan. Now, of course, here we see the wings and all the way out the neck. Here's Lyra, right here, next to it. Now I'll go back to that photograph I started the talk with, and here is the image of the Milky Way going through the constellation Cygnus. Here is Deneb, the bright star, and here is this pattern of material, and then this other weird little pattern over here. This is NGC 7000. And through a telescope, it looks like this. Here it is. It is called the North American Nebula. And you can see why. Here's Mexico, the Yucatan, Gulf of Mexico, a kind of fat Florida, and then up the East Coast. You can see why they call it that. Now, next to it, this ball of gas is called the Pelican Nebula. And you can sort of see it. Here's its beak that holds more than its bellycan, and its kind of odd head and its eyes. These objects are very extended. As you can see from the previous photograph, this is a magnification of 1. If your eyes could capture enough light, this is what it would look like. You see, it's very large, but it is relatively difficult to see because it is so diffuse. Photographs capture it very well, or if you're going to view it through a telescope, you can filter it with a specific filter, and it becomes much easier to detect. All of this material here is hydrogen, and you see it glowing, that characteristic red of hydrogen, from the energy being pumped into it by the stars surrounding it and within it. Well, folks, this is just a little sampling of what's up there in the late spring and early summer. And I wholeheartedly encourage you to get out and look up. And there's no better place to do that than in the Central Idaho Dark Sky Reserve, which is one of only 12 gold tier dark sky reserves in the world. And it's just right up the road, begins in Ketchum and Sun Valley and extends all the way up to Stanley. Okay. Now, either side of the road, almost 1 million acres of beautiful dark sky. Take advantage of it. Go out some night with a lawn chair. Maybe you have your Planisphere with you, a pair of binoculars, and just look up and admire this sky. Okay. Thank you. Are there any questions?
Tim, a question about telescopes. I'm
Yeah.
sorry, binoculars. What power of binoculars would you suggest if you want to do some birding or use it for other purposes, but maybe also want to do some night sky viewing with it?
Okay. I think the best binoculars are the 7x50s. Now, what that means is when you see those numbers on binoculars, the first number, 7, is the magnification. The second number, 50, is the diameter of the objective lenses, that is the big lenses that point toward the objects you want to view. That's their diameter in millimeters. So it would be that have 50 millimeter lens and give you the magnification of 7. These are great because they're easily hand-holdable. The other great thing about them is that the image that they form that strikes your eye is about 7 millimeters in diameter, which is the diameter of the fully dilated human eye. So when you go out at night and look up, you're getting all the light that that binocular can give you, and you can see. They are hand-holdable. I have a pair of them, and I use them all the time. They're great, and I'll put them on a tripod and look and just scan up the Milky Way in the southern Milky Way in the summer. It's just really beautiful. Those are really good binoculars. If you get more powerful, yes, it magnifies more, but it magnifies everything more, including the shake of your hands and the fact you've had too much coffee that morning or whatever. So I recommend, the 7x50s.
Thanks, and have a lovely evening, everyone. Thank you, Tim.
All right, thank you. Thank you all. Bye-bye.